5 years after Gödel proved his two incompleteness theorems, Alan Turing in England was doing something similar for computers. First, Turing defined what is called a Turing machine, a device able to manipulate symbols on a strip of tape following a set of rules. In a sense, a Turing machine is a kind of perfect computer with an unlimited amount of memory. The device and the tape are what we now call the hardware, while the set of rules is the program or algorithm. Turing showed that any Turing machine suffers from the halting problem. In brief, the halting problem is the inability to tell if a program will stop after a finite number of steps or if it will keep going on forever. Of course, for simple programs, it is easy to know if it will stop running or not. For example, a program like this one with these two lines to print question reality would run forever, printing the same thing, question reality, as we can see directly. But for more complicated programs, Turing showed that it is impossible to decide whether the program will stop or not. Just as in the case of Gödel's mathematics, Turing's halting problem is an example of an undecidable problem. Turing showed that it is impossible to construct a single program that leads to a correct yes or no answer to whether the program will stop. This is the central point, since it means that there will always be propositions whose truth or falsity cannot be decided in a finite number of steps. This is exactly like the liar's paradox that we have found in Gödel's incompleteness theorems, when you can't know if a sentence like, "This statement is false," is true or false. In a sense, it is both. Gödel and Turing's results may be disappointing for those who believe in a Platonic dream of mathematical perfection. However, they also show how amazing human creativity is. By exposing a crack in the building of mathematical perfection, they illustrate our attempts to build an ever-growing island of knowledge. By analyzing the nature of truth in mathematics and in computer science, Gödel and Turing expose the limitations of our own logical constructions, which can never be close upon themselves. This means that at least within our current logical framework, we can't conceive a system of knowledge constructed with the human brain that is formally complete. If you are a Star Trek fan, this means that we can never be like Spock and his fellow Vulcans. In fact, if you take the analogy seriously, a creature like Spock, or any perfectly rational entity, animal or machine-like, cannot exist. There is always going to be some imperfection, some unexpected surprise that makes the pursuit of knowledge unpredictable and free.